So this is also a new talk for me because Nick Bostrom covered a lot of the material that I would usually put into a talk, so I had to quickly scurry off and design another talk that would not overlap with his talk. Let's start with an old tragedy of science, that is a case where some scientists screwed up. Why don't predator-prey populations crash? You would think that, you know, if you ran a simulation or something, you would find that the population of foxes, when the rabbits would get out of whack, there'd be too many foxes, not enough rabbits, they'd all starve. Now, back in the 1960s, they had this brilliant notion, which is that if you would partition the fox population into groups, then groups of foxes that reproduce too much and eat all available rabbits will starve and be eliminated from the gene pool. So by selection on groups, foxes will evolve to restrain their own reproduction. This was an actual much talked about theory before the 1960s, back when biologists had, when a large majority of professional biologists had no idea how evolutionary biology worked, really. Foxes will evolve to restrain their own reproduction. Okay, that basically never happens. You don't have a gene for not reproducing that becomes dominant in the gene pool. Specifically, group selection, although it was a very popular sort of theory, was tremendously difficult to make work mathematically. Before the 1960s, before what's now called the Williams Revolution, people would postulate all sorts of nice pro-social group benefiting adaptations, and they would point to group selection as their theory for how evolution could actually do that. But it's mathematically extremely difficult for group selection to work. One example is in simulation, if the cost to an organism of a gene is 3% of its own fitness, and it benefits its neighbors so much that pure altruist groups have double the reproductive fitness of pure selfish groups, and group size is 25, and 20% of all deaths are replaced by neighbors from another group, the result is polymorphic for selfishness and altruism. That means that if the cost is 5% of fitness, or if pure altruist groups are less than twice as fit as pure selfish groups, then you do not get, then you would just get the selfish gene. The selfish gene would win. If you look at the statistics of a human maternity hospital, where around the same number of boys and girls are born into each generation, you can see at a glance that individual selection pressures beat group selection pressures on humans. You know, you might imagine that if you had more girls born and fewer boys, that you would have more mothers, you would be able to reproduce faster. But if you had an equilibrium like that, then any gene for birthing more boys would be able to make a genetic killing in the next generation, because boys would, each child would still have half of its genes from the father, half of the genes from the mother. The pool of boys and the pool of girls would make roughly equal genetic contributions to the next generation. So if there are fewer boys, then you can make an individual genetic killing by birthing more boys. If there are fewer girls, you can make a genetic killing by birthing more girls, regardless of what's good for the group. So you can just look at a glance at the human maternity hospital, and you can see that the forces of individual selection are far stronger than the forces of group selection on humans. And there is no, and we would now say that there is no known case of a group-selected adaptation in any mammal. One might even say no known case of group-selected adaptation, period, but that is slightly more controversial. The part about no mammal, we know. In point of fact, why don't predator-prey populations crash? Well, when I was young, my father said to me, why don't people on Australia fall off the globe since they're standing upside down? And my father said to me, aha, it's a trick question. Actually, people fall off all the time. Just in case you're wondering what kind of family I came from. And indeed, this is a wrong question. The answer is predator-prey populations crash all the time. But later on, even though the mathematically required conditions for group selection are ridiculously extreme, A mad genius named Michael J. Wade took a laboratory population of tribolium beetles and implemented the extreme conditions needed for group selection. Selection on groups of beetles for reduced population that was so severe that group selection could mathematically overpower individual selection. So what do you think happened when group selection, this same force that was once appealed to talk about all sorts of wonderful aesthetic, humane solutions like be nice and restraining your own breeding. This is what biologists before the 1960s appealed to group selection was supposed to produce. So Michael J. Wade took some populations of beetles. He eliminated all the beetle populations that grew the fastest, leaving only the beetle populations that grew the slowest. What do you think actually happened? Take a moment to predict it. But if you've actually read about this before, then don't predict it. The group.
No, I haven't actually. I just guessed cannibalism.
Well, yes, you did very well because, of course, the actual solution group selection produces is eat their babies. You know, not your own babies, of course. You go around and find the other organisms' babies and you eat them, especially the young girls, of course. Those are the tastiest. Om nom nom. Think of your brain as an engine that searches for solutions ranking high in your preference ordering, using limited computing power. Now, if your tribe was faced with the sort of population problem that Michael J. Wade presented his beetles with, or the foxes had with the rabbits, then for you, the solution, let's all have as many children individually as possible and try to eat each other's babies, especially the girls, would rank so low in your preference ordering that your brain would not even suggest it. Like you wouldn't see that as an option because your brain has limited computing power and there is no point in generating solutions that weird and that low in the preference ordering. So if you try to understand evolutionary biology by putting yourself in evolution's shoes and asking how you would solve a problem, you won't even see evolution's answer as a possibility. You have to learn to think like this non-human optimization process, which early biologists didn't. And indeed, there is much eleemosynary literature in evolutionary biology devoted to training you to stop thinking like a human who will come up with nice solutions and start thinking like natural selection and coming up with which genes are actually likely to rise to universality in the gene pool. The relevance to AI, of course, is that if you, so for example, yesterday, Schmidhuber, who unfortunately is not here today, gave us a certain reward criterion and suggested that it would be maximized by art. And, you know, having been through this sort of conversation for quite a while now, I sort of squint at that and say, okay, so art fits there, but what else besides art fits there? How about sets of black boxes encrypted by an external mechanism using a key that can be reliably recovered in 5 minutes? Then you could achieve a lot of compression that way. In general, what sort of goes wrong with your mind when you try to understand this sort of non-human optimization process is something like persuasive rationalization. Like, let's say I'm buying an entire chocolate cake, going to sit down and eat it. You ask me, hey, why are you buying that entire chocolate cake? I thought you were on a diet. Oh, because I want to help the sugar industry. Helping the sugar industry is very important. What's wrong with this claim over here? What is wrong with the claim that you are optimizing the criterion of helping the sugar industry by buying the chocolate cake? Well, you could just mail them a check. And instead of getting only the tiny portion of the gains from trade that are captured by the sugar industry when you know, by the time you buy the cake and it has been marked up by the cake manufacturer in the store and so on, you could just mail them the check directly. So strategy X, in this case, eating an entire chocolate cake, suggested by criterion 1, in this case, chocolate cakes are tasty. You try to justify that by an appeal to criterion 2, helping the sugar industry. But you can tell it's a persuasive rationalization because just mail them a check, strategy Y optimizes criterion 2, help the sugar industry. It comes a lot closer to maximizing criterion 2. So let me just sort of skip ahead over here. And so in the tragedy of group selectionism, there was a biologist saw an ecological problem of the limited rabbit supply. They imagined how they would solve that problem by having the foxes cooperate to restrain their building. Now, this was really sort of suggested by their human, nice aesthetic sense of values. And then someone pointed out to them, hey, wait a minute, that is not how evolution works. But by this time, they'd gotten there emotionally attached to their lovely aesthetic view of nature, foxes and rabbits in harmony. People would actually say things like that, before the 1960s. And so they invoked their brain's persuasive rationalization module, not that they decided to do that, that just sort of happened automatically when they were defending their mistake, and sort of tried to persuade evolution to see it their way by appealing to evolution's own stated moral principles of promoting reproduction, sort of like trying to, hey there, natural selection, you could actually, you could get some reproduction done by doing things my way and having the foxes restrain their breeding, yeah. But unfortunately, evolution itself does not start with human aesthetic preferences and then figure out a way to rationalize how that helps reproduction. Evolution is just the process where the genes that build foxes, that produce more baby foxes, become more prevalent in the population. So after you are done sort of nudging the non-human optimization process and claiming that it ought to do nice things for your clever reasons, that your prediction fails because the process itself does not work that way, and it's not, and your thing that sort of maybe helped reproduction a bit didn't maximize reproduction. It didn't fit the criterion as well as some other things. Sort of like, okay, sure, art maximizes Schmidhuber's criteria. Art might produce some reward for Schmidhuber's internal reward criterion, but having a sequence of black boxes that produced by an external device where you can recover the key in 5 minutes will optimize it even more. Oh, and let me. And a little similar story that related story you might find entertaining. So Less Wrong is a community website devoted to human rationality, and it's got all these lovely sequences on things like how to actually change your mind sometimes. This will become relevant in a moment, I promise. So newcomer to Less Wrong goes, hi, I've read through the sequences, and I'm an egoist. Well. So of course he was like immediately asked, so if you could take a pill that could numb your conscience and no one would ever find out, how many babies would you kill for $1? Because you see, people who call themselves egoists, they may have this sort of verbal philosophy of selfishness, but their actual options are being generated by the full range of normal human values, and then they appeal to selfishness in order to justify those options that were generated by other sources. They aren't actually egoists, because if they were actually egoists, of course, they would see nothing wrong with killing babies for $1 as long as they didn't get found out. Oh, and the response one day later, okay, I thought about that for a while, I'm not an egoist anymore. This only happens on Less Wrong. I don't think I've ever seen that happen anywhere else on the internet. So as this person realized, they'd never actually used egoism to select their actions. They'd used normal human preference to select their actions, but then justified them by rationalizing to this simple principle of egoism. You get a lot of people proposing simple principles that are all we need to build into a friendly AI, and everything will be hunky-dory forever after. And that's because they use their full range of human preferences to generate and select their actions, and then they justify them by appealing to this principle, which can actually be maximized a lot more by things like eating babies, killing babies for $1, or having black boxes encrypted by an external device. So, the point. People don't notice when simple optimization criteria imply humanly ugly choices because their own brains don't generate the strategies for consideration, and people think they can pack all sorts of nice things into simple principles because they make their choices using full human values and aesthetics and then rationalize those choices by persuasively arguing to that principle. So this is another thought experiment. The reason why I couldn't come up with an abstract for this talk is that it's a series of persuasive historical cases or thought experiments, and I just couldn't figure out an abstract for that because I was too busy finishing the talk. So let's say you're in a world where no one knows what's really going on with addition. Addition is one of the mysteries. And so, of course, modern computer scientists are trying to build artificial addition. And they do this with a logical addition device, which, of course, as anyone who is familiar with symbolic AI will realize, will naturally contain all sorts of nice propositional logic statements stating that the plus of 7 and 6 is 13. And of course, all these little suggestively named Lisp tokens over here are given their meaning by the larger semantic network in which they are embedded. And it turns out that doing artificial addition this way is very expensive and time-consuming, and they've only got artificial adders that work up to the number 60, and getting your artificial adders all the way up to working with like general addition in the ranges of thousands or millions, as humans can do, is thought to be decades away and so on. And so you've got all sorts of, and by the way, don't worry, this will be relevant to friendly AI. I've got all sorts of lovely comments about this problem of artificial general addition. For example, there's the view that artificial general addition is difficult because of the framing problem. What 21 plus is equal to depends on whether it's plus 3 or plus 4. So you need to program a huge network of arithmetical facts to cover common sense truths, and then you'll get artificial general addition. Or you need an artificial general arithmetician that can understand natural language, so instead of being told that 21 plus 16 equals 37, it can obtain that knowledge by reading the web. Or you need to develop a general arithmetician the same way nature did, evolution. Top-down approaches have failed to produce arithmetic. We need a bottom-up approach to make arithmetic emerge. We must accept the unpredictability of complex systems. Neural networks, just like the human brain, they can be trained without understanding how they work. Neural networks will do arithmetic without us, their creators, ever understanding how they add. Or actually, you just need calculators as powerful as the human brain. And Moore's law predicts that calculators as powerful will become available on April 27th, 2031, between 4 and 4:30 in the morning. Or maybe that's not enough. Maybe we've actually got to simulate the detailed neural circuitry humans use for addition. Or Gödel's theorem shows no formal system can ever capture the properties of arithmetic, and classical physics is formalizable, so hence an artificial general adder must exploit quantum gravity. If human arithmetic were simple enough to, et cetera, et cetera. Haven't you ever heard of John Searle's Chinese calculator experiment? See, it doesn't really know what the numbers mean. Probably we'll never know the nature of arithmetic. The problem is just too hard for humans to solve. So I usually tell the story with the moral that when you're missing a basic insight, what you have to do is actually understand what's going on inside addition. And until you understand that, you're screwed. You'll come up with all sorts of clever workarounds and things that you can say about the problem in ways that sound like they might solve it that will sound clever even if you don't quite know what you're doing. But it's actually impossible to talk sensibly about solutions until you are no longer confused. It's quite important to recognize what people sound like when they start talking about something about which they are fundamentally confused. This is what they sound like. It's good to be able to recognize that. Today's moral, though, I'm actually just going to take a simpler moral, which is that if you have to put in an infinite number of special cases, it means you didn't understand the underlying generator of the behavior. This moral will shortly become relevant. So, next thought experiment, the outcome pump. Let's say you have a time machine. What sort of fun machines can you do with a time machine? Go back to yesterday and throw a pie at yourself, or achieve omnipotence. So let's say that you build a device which automatically resets time unless some desired outcome occurs. So in other words, you just sort of keep resetting time back to some previous state until you get the outcome you want. Now you have a physical genie device. Time machine equals genie. talk about a little time machine reset device, because if you talk about genies, you are tempted to think of them as minds and anthropomorphize them and assume that they would do what you would do in your shoes. We want to talk about a physical genie, the little time machine reset device, because it lets us talk about an optimization process, the resetter, just using the language of physical things without invoking mental entities, and that may help us be a little less anthropomorphic. That's why I opened with the example of natural selection. Natural selection is a non-human, non-mental optimization process, and that doesn't mean people don't anthropomorphize it, but it means you can give them very stern looks when they do. So you take your physical genie and you want to solve the grandma extraction problem. Now, if it's a regular old genie, you just say, I wish for my grandma to be outside the burning house. There's a house on fire, your grandma's in it, you want to get it out. That is the grandma extraction problem. But we don't have a genie, we have a little time machine device. So first thing, we've got to actually specify in some way. It can't be assumed to automatically understand what we want. We've got to describe what we want to this physical genie that clearly can't understand language because it's just a plain old physical time machine. So how would you specify this goal? Well, even if you can't understand natural language, you might, iPhones can take pictures. We have software that can understand pictures. We might hook up some kind of scanner that can identify objects in its vicinity, by magic. And we'll scan in a photo of grandma's head and shoulders. We'll use object contiguity to select grandma's whole body. And we will say that the probability of resetting time decreases as grandma gets further away from the center of the house. So this, where I'm actually sort of skipping over a bit of the background of how I usually explain this. Like, the idea is that you can specify a quantitative utility function for this kind of physical outcome pump by saying the higher the utility, the less likely you are to reset, and so you're more likely to end up with an outcome with higher utility. In any case, so in this case, we're specifying that the outcome pump is going to try to select an outcome in which grandma, identified by object contiguity and a photo, is far away from the center of the house. You have now told the genie to get grandma out of your house. So the gas main under the building explodes. Grandma's body is hurled into the air, thereby rapidly increasing her distance from the former center of the house. And there's a little button on your time machine that you're supposed to push if something goes drastically wrong, which almost certainly resets it. It's called the regret button. Of course, you never experience pressing it because all those probabilities have been wiped out. But in this case, a flaming wooden beam drops out of the sky and smashes you before you can hit the emergency reset button, thus causing the time machine to think everything's fine. Now, if you were talking about a actual genie, a mental genie, a genie that understood what you were saying, you might be tempted to blame it. But as long as this is a physical optimization process here, there's no point in blaming it for anything any more than there's a point in blaming natural selection for producing baby eating as the outcome of group selection. You simply programmed in the wrong utility function. It's not the fault of the time machine, it's the fault of the function you gave it to maximize. So if this were a mental genie, we would say, I wish for my grandma to be outside the burning house and alive. So you try to write something into your time machine outcome pump that recognizes whether grandma is dead or alive and makes sure that she is breathing at the time she exits the house. And of course, she ends up in a coma. The open source wish project tries to develop inescapably good wishes. This is their version 1.1 of their wish for immortality. I wish to live in the locations of my choice in a physically healthy, uninjured, and apparently normal version of my current body containing my current mental state, a body which will heal from all injuries at a rate blah, 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 blah. Now, remember the previous lesson about needing to patch an infinite number of special cases? Because you didn't understand addition and therefore you had to program in all the knowledge manually. Let's say you were trying to build a chess AI. You could imagine that you would build a chess AI by having a human look at a bunch of chess positions, rate whether those chess positions are good or bad, or have the human look at a bunch of chess positions and say, what is the best move in each chess position? And then program those chess positions and their best moves into the chess-playing AI. The problem with this, of course, is that there are too many chess positions. The key insight that you need is that what makes a move good is that it leads to a certain range of board states that we have designated as winning, and that we want the chess-playing AI to navigate to one of the board states known as winning. And until you achieve the insight of game trees, you cannot build a chess-playing AI. So, grandma extraction problem. We have cases like grandma is dead is worse than grandma is alive but burned is worse than grandma alive and healthy. Suppose a wormhole opens and transports grandma to a desert island. Well, that's better than her being dead, but it's worse than her being alive, well, healthy, untraumatized, in continual contact with her social network. Is it okay to save grandma at the cost of a fireman's life, at the cost of the family dog's life, at the cost of 2 murderers' lives? Is it worth a 0.000000001% risk to grandma to save the family dog? Would you destroy every extant copy of Bach's Little Fugue in G minor to save your grandma? What algorithm are you using to decide all these cases? How do we capture the generator? You're checking the value of the distant consequences, and you're implicitly checking all the components of your utility function. People like the open source wish project are generating all the clauses of this wish by imagining events with negatively valued consequences and ordering the genie, don't do that. This is one of my favorite sentences ever. It's from William Frankena's Ethics, and I first encountered it in the Stanford Encyclopedia of Philosophy article on what things have terminal value. What things do we value in themselves and not for their consequences? Life, consciousness, and activity, health and strength, pleasures and satisfactions of all or certain kinds, happiness, beatitude, contentment, truth, knowledge, true opinions of various kinds, understanding, wisdom, beauty, harmony, proportion in objects contemplated, aesthetic experience, morally good dispositions or virtues, mutual affection, love, friendship, cooperation. Boy, you're ever feeling down, you can just read this sentence over here and remember everything that makes life worth living. If the genie is searching more past through time than you, if you're dealing with the genie that will be considering options that you didn't imagine at the start of the problem because you were not smart enough to imagine them, because you did not search all the past through time that the genie could take, then no wish that you make to that genie is safe unless the genie itself is checking all the consequences of any strategy it considers using the entire utility function. If the genie has no component in its utility function for music, that means that changes to music are value neutral in the genie's evaluation, and that means that as far as the genie is concerned, if you can destroy all copies of Bach's music to prevent someone from breaking a leg, where it knows that breaking a leg is bad, but it has no component in its utility function for the music, that's great. That's fine. So this is the hidden complexity of wishes. That whenever you consider, well, is that a good way to wish something? The strategies to implement simple-sounding instrumental goals are chosen using the full array of terminal values that forbid negative consequences and optimize positive consequences. This goes on in the background. You're probably not even aware of ever consciously saying, should I blow up the house in order to get grandma out of it? No, your brain doesn't even generate that as an option. It's too low in your preference ordering. But the reason it's low in your preference ordering as a way for getting grandma out of the house is that you value grandma being alive. You weren't even aware of considering that, but it was a consideration that was there the whole time. And thinking about this as a purely physical device, a little time machine that resets time unless some sort of physically specified condition is achieved, sort of reveals why a time machine like that, an outcome pump like that, you might think it would grant you omnipotence. It's actually too dangerous to ever be used. It searches all the paths through time, and unless you can program William Frankena's entire value list in there, plus everything Frankena forgot to talk about, it's going to stomp on one of your values in the course of implementing what sound like perfectly reasonable wishes. Bill Hibbard. We can design intelligent machines so their primary innate emotion is unconditional love for all humans. First, we build relatively simple machines that learn to recognize happiness and unhappiness in human facial expressions, human voices, and human body language. Then we can hardwire the result of this learning as the innate emotional values of more complex intelligent machines, positively reinforced when we are happy and negatively reinforced when we are unhappy. Train superintelligences so their reward function is smiling humans. Naturally, if you actually tried this, the galaxy would end up tiled with tiny molecular smiley faces. It just seems obvious. What could he possibly have been thinking? Oh, incidentally, the people who did the DNA molecular smiley face stuff, some of them had read my work, and like one of them actually emailed me to say, oh, I produced some tiny molecular smiley faces. It has begun. This is the sort of friendly AI proposal that you get when people use qualitative physics to think about friendly AIs. So qualitative physics is a psychological study of a certain kind of reasoning. So for example, this diagram says that if you increase the burner temperature, that will increase the amount of boiling going on. And if the amount of boiling going on increases, that changes the derivative, that decreases the derivative of water. In other words, the water is already boiling away, but now it's going to boil away more quickly when there's more boiling going on. And this says that you can turn on the burner to get rid of water. So presumably, Bill Hibbard was thinking something along the lines of happy people smile more. Smiling reinforces the AI behavior. The AI will therefore do things that make people happier. Happier people have more utility. Therefore, building a superintelligence reinforced by human smiles is, according to this graph, good. And of course, you hear a very large category of proposals that one might term apple pie AI, which go like this. Apple pie is good. Nuclear weapons are bad. All we need to do is build a superintelligence that will give us lots of apple pie and not use any nuclear weapons. No, seriously, that thing that Hibbard wrote was in a peer-reviewed journal. I hear this all the time. Nothing remotely like this approach will ever work, ever. And if I hear one more proposal to build an AI that promotes liberal democracy, I'm going to scream. So the natural next thing you might think of is, okay, build a superintelligence that is optimizing William Frankena's entire value list. The problem is when you get down to the bottom of that list, you get to power and experiences of achievement, self-expression, freedom, peace, security, adventure and novelty, and good reputation, honor, esteem, etc. That etc. is the dangerous part, really. Dialing 9/10 of my phone number correctly does not reach 9/10 of Eliezer Yudkowsky. What happens if a superintelligence's utility function has one wrong number? It is missing just one little component of value. The n-armed bandit problem says that you have a number of slot machines in front of you, and you are trying to determine which of these slot machines, when I pull the lever, gives me the highest expected payoff. The human solution, of course, would be to pull your favorite levers so far and occasionally get bored with the known levers and try pulling some new ones. In general, this is called an exploration-exploitation trade-off. It is the problem that boredom solves in humans. There's also the Bayesian optimal solution to an exploration-exploitation trade-off is to have a prior over the one-armed bandits, the slot machines, update your beliefs about them based on your observations of the payoffs they've delivered so far. And here's the thing. If you know how long you're going to have, how many pulls you're going to have on these bandits, then any piece of information you can obtain about them is more valuable when you obtain it closer to the start of the problem. Any piece of information you obtain, you get to use on more future occasions if you obtain it earlier rather than later. So occasionally going exploring is not an optimal strategy for maximizing the payoff from the one-armed bandits. The optimal strategy is to do all your exploring first until you have updated your beliefs about the one-armed bandits and the expected value of information has dropped below the threshold of the most rewarding bandit observed so far. And then once you have gathered all the information you're going to gather, you just pull the best lever over and over until time runs out. That is the base. Did I make an error there?
I think so. I mean, what if you've only got rewards between 1 and 10, and then you keep pulling until time runs out, and you get -1 million? No.
Well, if that first of all, if that possibility exists in your prior,
yep.
For one thing,
if that one of them is going to do -1 million.
Okay. So if you have no idea which one it is, then you might as well pull the one with the highest
once you've
level.
done that, then you know it's the other ones aren't that one.
I mean, it seems there's
well, sure. Then of course, yes. Indeed, you can have a case where you're pulling the one that's best, and then you get an unexpected piece of information about it, and then you start switching again. So yes, that indeed can happen. But if that doesn't happen, and the AI will generally not expect that it will happen at the time that it starts pulling the best lever, it'll just pull the best lever over and over again. The point is the solution does the exploration exploitation problem that boredom solves in humans. Human boredom is not the only way to solve this problem. And if you ask what sort of convergent instrumental value you're likely to get, it's going to be first do all your exploring, find the configuration that maximizes your utility, exploit that configuration over and over again. That's the convergent instrumental one. Humans have a terminal value for doing new things. Imagine running into aliens who have a different emotion of boredom than we do. In particular, they are more easily amused. In particular, these aliens have a narrower definition of what constitutes the same thing for purposes of boredom. So if you show them the same picture with 1 pixel changed, they say, that's a different picture, I'm not bored anymore. What would this alien civilization look like if we encountered them? Probably something like this. You know, just the moment of maximum fun over and over and over and over and over again. I will take a moment to comment at this point that you have to solve the friendly AI problem in order to get an interesting universe full of strange alien beings whose art and science we cannot imagine. You've got to solve. The friendly AI problem isn't about preserving humanity as it is now until the end of time. If you don't solve the friendly AI problem, you don't get a strange, wonderful alien universe. You get things that you didn't even think about as particularly human values, like boredom, which because they're left out of the utility function, you lose everything of value. If an alien civilization doesn't have the same kind of boredom we do, if as far as they're concerned, changing 1 pixel of this frame makes it a different experience that is no longer boring, then their entire civilization would look uninteresting to us. Similarly, if you have a paperclip maximizer, it wants to make paperclips. That's all its utility function is. It doesn't have any function in its utility, any term in its utility function for boredom. And you don't get to say, well, we don't have to build in boredom as an explicit terminal value. It's a convergent instrumental goal, because the choice is not between the human version of boredom and an AI that experiences nothing analogous to boredom. Our own boredom is a product of our evolutionary origin. The fact that we are built by natural selection, that natural selection is stupid, means that a lot of things that are in a sort of natural selection sense instrumental goals are in us terminal values. And for that matter, our boredom could easily be, our style of boredom could easily be tied to our neural implementation. It could be a matter of neurons adjusting to the same reward over and over and getting bored and go looking at something else. If you look at an ideal Bayesian decision agent and ask what kind of boredom is a convergent instrumental value, then there is a convergent solution to the exploitation trade-off. And that solution leads to what we would regard as a boring, worthless, valueless future. This is why we have to solve the friendly AI problem. It's not about the values that you think of as uniquely human. It's about the values you don't even think of as human, but which are there nonetheless, and if they are lost, if even a single one of those values is lost, losing a single dimension of value can lose nearly all the expected value of the future, everything we were hoping to get out of those galaxies. Besides boredom, some other cases where you lose a single dimension of value, you lose the entire thing. Consciousness, you got everything there in the utility function, only it doesn't talk about consciousness or doesn't talk about which sort of things are conscious. And from our perspective, the entire galaxy is turned into a wonderful literary novel with no one to read it. External reference of subjective sensations. You have an AI that is sort of carefully optimizing your subjective sensations but doesn't want anything to be behind it. That's not part of its utility function. You have this wonderful, perfect girlfriend and you feel very free, but your girlfriend is just wallpaper and your feeling of freedom is produced by artificially stimulating your little freedom of sensation lobe in there. Little sensation of freedom lobe in there. This is I presume I'm running out of time here, am I correct? Or?
At some rate, we are, yes.
So if you want to have time for us just before we have to rush off for food, you might want to speed up.
If within the next 5 minutes we have time for the normal amount of Q&A.
Okay, so I will skip a little extended thing that will follow this last example. This is an anecdote I have repeatedly heard presented as fact. I've been unable to track down the original of it, but that doesn't mean it's not true. And the story goes like this. The Army was trying to develop a neural network that would detect tanks. And they gave some photos of tanks and of non-tanks, scenes with tanks in them and without tanks in them, to their AI researchers. And the AI researchers trained a network until it could distinguish the tanks and the non-tanks, and then they, from the same set, took the test photos in, and the neural network that had been trained in the training photos could distinguish the test photos just as well, got 100% accurate classification. And then they took it out and gave it to the Army, and the Army came back and said this doesn't work at all. And it turned out that all of their pictures of tanks had been taken on cloudy days. All of their pictures of non-tanks had been taken on sunny days. They had built a cloudy day versus sunny day classifier instead of a tank classifier. The simplest boundary around the data is not always the boundary you had in mind. If the training cases and real-world cases aren't from exactly the same independent, identically distributed context, no statistical guarantees apply. And if you imagine Terry Schiavo, if I'm pronouncing her last name correctly, Schiavo. So Terry Schiavo would not have been something we would have encountered in our ancestral environment. If you try to classify people as alive or dead in the ancestral environment, you have a litany of plus cases and minus cases, where if you draw the simplest boundary around it, it's likely to talk about the difference between alive and dead being the difference between breathing and non-breathing, say, or moving and non-moving. And the case of Terry Schiavo is outside the training cases of the ancestral environment. You can't, if you presented an AI with the ancestral environment cases and tried to train it to distinguish between people and non-people, the advance of technology would have produced all sorts of exotic cases that it couldn't classify, that wasn't guaranteed to classify using the training data, probably wouldn't classify correctly because the simplest boundary used for making predictions would not be the moral boundary. This is, over here I'm just sort of like talking about some material that I was going to cover later and skipping over it, essentially. There are several morals you could draw from this, but one of the morals is the categorization that you want the AI to draw. Sometimes without even realizing it, it's not there in the data. It's there in your utility function, but it's not there in the data itself. This is a class of problems I'm not really going to get a chance to talk about because I'm skipping straight through. But it's why it's difficult to just give the AI a set of training cases and say, this is our ethics. Because the shadow of your ethics on that data set may not capture all the features of your ethics. That's the difficulty with just trying to get Frankenna's entire value list, including the et cetera, by taking a large corpus of ethical dilemmas and training the AI on them. But I didn't actually quite get to go through all that because I'm out of time. And I will also skip the summary of the talk and go straight to the end due to being out of time. Thank you.